So, good morning, friends. How are you? Everyone is fine. So, I think that you must have revised all the previous topics, and now we will go to the second most important component of induction motor, that is rotor. So, we will go to the design of the rotor. So, as you look into you can see the image, that is, this is the end ring, this is the end ring. First of all, rotor is the rotating part in the machine. So this is the end ring, this is the conductor bar, this is conductor bar, and this is aluminum end rings, you can say aluminum end ring. This is the shaft, this is the shaft, and this is fan blade. This image, this arrow is indicating fan blade, and this one is laminated iron core. This is laminated iron core, and these are the aluminum bars. So these are the aluminum bars, these are laminated iron core, these are fan blades, this is shaft. So we will go ahead with the rotor type. So in a squirrel cage induction motor, squirrel cage induction motor, the rotor it is very rugged. Simple construction is there, and also the rotor is cheaper, but starting torque is low and the speed control is not very easy. In a squirrel cage motor, this is the rugged, simple construction is there, cheaper in price, but low starting torque and speed control is not very easy. But in slip ring induction motor, rotor, you can say this is complex type and the cost is also high. Starting the speed can be controlled by external resistance on rotor side. So there is some advantage and some disadvantage of both the rotor type. Now we will discuss about air gap, advantage of large air gap. So the advantage of large air gap is, please keep writing. Advantage of large air gap is increased overload capacity, reduced zigzag leakage, you can say, overload capacity get increased, and cooling also get increases there. Due to larger air gap, there is reduced magnetic pull, that means less effect of eccentricity. Reduced tooth pulsation, that is variation due to slotting is small, so the tooth pulsation also get reduced, magnetic pull get also reduced, and the noise will also get reduced due to reduced zigzag reactance. So once again I am repeating the advantage of larger air gap, that will increase in overload capacity, also cooling get increased, and reduced magnetic pull, reduced tooth pulsation, and reduced noise. What are the disadvantages? As we all know that everything has some advantage and some disadvantage. So the disadvantage of large air gap is the magnetizing current will get increased. The magnetizing current will get increased, and the power factor will also get reduced. The power factor will also get reduced. So once again I am repeating, advantage of large air gap: increased overload capacity, increased cooling, and reduced magnetic pull, reduced tooth pulsation, reduced noise. Disadvantage: increased magnetizing current, power factor will get reduced. Now air gap, hence optimum length of air gap is necessary. So what will be the optimum length of air gap? So LG is equals to 0.2 into 2 root under DL mm. D and L dimension to be put in meter. So outer diameter of rotor dr equals to d minus 2 into Lg. So you can get the value and put in this equation, you will get the value. Now number of rotor slots. Proper selection of number of rotor slots with respect to number of stator slots. Proper selection of number of rotor slots with respect to number of stator slots. Proper combination of stator and rotor slots, that will impact proper combination of stator and rotor slots, that will impact so many parameters like cogging, crawling, hooks and cups, noise, vibration. So selection of number of rotor slots. Slot combination, we can find slot combination SS minus SR, SS SR, that is not equals to plus minus 1 plus minus 2 P plus minus 1 comma P plus minus 2. The performance minimize the noise and vibration. The S2 SR is not equals to plus minus Kp by 2K is an integer, that will to avoid dead points or cogging. So to avoid different phenomena like crawling, cups, for good operation, low reluctance, we need to select the number of rotor slots. Thumb rule, SR is 15 to 30% higher or lower than SS. Thumb rule is SR is 15 to 30% higher or lower than SS. Now we come to rotor current. Current through the rotor bars, that is the conductors. Current through the rotor bars, that is conductors. So IB equals to 6 into IS into TPH into KWS into cos phi divided by SR. So आपको लग रहा होगा कि everything is flowing overhead, नहीं ऐसा लग रहा है, everything is flowing overhead. So now please keep noting, otherwise you will miss. We have to go very fast. So now rotor current through rotor bars, that is conductor, IB equals to 6 into IS into TPH upon SR into KWS into cos phi. IS is a stator current per phase, TPH is stator turn per phase, KWS is stator winding factor, and cos phi equals to power factor. Once again I am repeating, IB equals to 6 into IS into TPH into KWS into cos phi divided by SR. IS equals to stator current per phase, TPH stator turn per phase, KWS stator winding factor, and cos phi is power factor. Cross section of the rotor bar, high current density AB equals to IB by delta R. Low area, more resistance, more starting torque, but more copper loss, efficiency reduced. When the losses will be more, the efficiency will get reduced. Since rotor is better cooled, higher delta than stator is allowed. So it must be 427 A per mm square. This is the conductor bars in the rotor. This is the conductor bars in the rotors. Now shape of the rotor slots. So shape of the rotor slots is open, semi-closed and closed. Semi-open, this is semi-closed and this is closed. So fully closed, semi-closed with small opening. Choose rotor bar, rectangular bar dimension from standard table. Width, thickness, SW, SR and depth, DSR. Rectangular conductor table is given here. You can easily choose these values from the table. Now rotor teeth. Width of the rotor teeth should not be too less, otherwise flux density may exceed the limit of 1.7 Weber per meter square. Width of the rotor tooth should not be too less, otherwise flux density may exceed the limit of 1.7 Weber per meter square. Minimum width of the rotor teeth WTR minimum equals to phi by 1.7 into SR by P into Li. So minimum width of the rotor teeth WTR minimum equals to phi by 1.7 into SR by P into Li. So you can see here, this is the WSR, this width is WSR, and this height is DSR, and this is WTR. this is WTR, this is WSR, this is D, and this is DR. So you can easily calculate all the values here by this formula. Actual width of the rotor teeth, rotor slot pitch at root minus slot width. This should be more than WTR minimum. So WTR equals to pi into DR minus 2 DSR divided by SR minus WSR. This should be more than WTR minimum. If this is not matching, recheck the standard table and get it matched. Now rotor core. Flux density in rotor core is generally equal or at most 10% more than the stator core flux density. BCR equals to 1.0 to 1.1 into BCS. Flux density in rotor core is generally equal or at most 10% more than a stator core flux density. So write down BCR equals to 1.0 to 1.1 into BCS. Depth of the rotor core DCR equals to phi by 2 BCR into Li. Inner dia of the rotor, shaft dia, Di equals to Dr minus 2 into DSR plus DCR. So please keep noting, I will not repeat and will go very fast. End ring current. Now we come to end ring current. Current through the end ring. What will be the current through the end ring? Sortings. This is this end ring sortings. So SR number of rotor slots, IB rotor bar current, and P is the number of pole. End ring current IE equals to SR into IB by pi P. So where SR equals to number of rotor slots, IB rotor bar currents, P number of pole. Now cross section of end ring, higher delta than a stator is allowed. So we had already learnt that AC equals to I E upon delta E. So you have to choose the suitable depth and thickness of the end ring. That will be rectangular. Now write one question. A 15 kilowatt 3-phase 6-pole 15 Hz squirrel cage induction motor has the following data. Stator bore diameter equals to 0.32 mm. Axial length of a stator core equals to 0.12 mm. Number of stator slot equals to 54. Number of conductor per stator slot equals to 24. Current in each stator conductor equals to 17.5 ampere. Full load power factor equals to 0.85 lagging. Design a suitable rotor giving number of slots, cross sectional, each bar and end ring. Now number of rotor slots, let us take 20% more rotor slots than a stator. So SR minus S equals to 0.2 into SS. SR minus 54 equals to 0.2 into 54, that will be equals to SR will be approximately equals to 54 plus 11, that will be equals to 65. Check for the consistency. So rotor bar design, rotor bar current IB equals to 6 into IS into TPH by SR into KWS into cos phi. So IB equals to 6 into 17.5 into 54 into 24 by 2 into 3 divided by 65. Now into 0.955 into 0.85, that you can calculate and tell me what will be the answer. So the IB will be 283 ampere. Let's take rotor bar current density 6 ampere per mm square. So rotor bar area AB equals to IB by delta R. So AB equals to 283 by 6, that is equals to 47.2 mm square. From a standard table size, let us take 25 into 1.9 mm square bar. So IE equals to SR into IB by pi P. So this IE will be equals to 65 into 283 by pi into 6, and when we calculate, this will be equals to 976 ampere. Let us take the end ring current density equals to 6.5 ampere per meter square. So area of end ring A equals to IE by delta E. A equals to IE by delta E. So A equals to 976 upon 6.5, that will be equals to 150 mm square. So end in dimension 15 mm into 10 mm. Now write down the next question. Design a 2.2 kilowatt 400 volt 3 phase 50 Hz 1470 rpm squirrel cage induction motor. Efficiency equals to 0.8, power factor equals to 0.825. Design for low cost. Assume BAV equals to 0.44 Weber per meter square. AC 21,000 ampere per meter. Use star delta starter. So you can do in your homework this question, and hope you have understood all the things. If any doubt, please ask me. So no doubt. Okay, you can revise and come to me later on if in case of any doubt. And in next class we will discuss very important topic, that is performance calculations. सारा चीज तो ठीक है, बट मोटर काम कैसे करेगा? व्हाट विल बी द परफॉर्मेंस? मोटर चलेगा कैसे? हाउ द मोटर विल रन? व्हाट विल बी द एफिशिएंसी? What will be the life cycle? So we will calculate, or we will learn about the performance calculation in the next class. Thanks. Have a nice day.